Hey everybody, it's Miss Hill, and I am back again for our final video of Module 3. So we are preparing you today for your Module 3 test, and to do so we wanted to create a cheat sheet. And that term is just meant to support you in using these notes when you take your test. So when you go in to complete your Module 3 test, please bring these notes with you. We are going to go over 7 problems today. And if you notice, there are 7 problems on the actual Module 3 test. So, I bet those problems we go over today are going to be super similar to the ones you see on your test. The test will cover the Pythagorean theorem as well as volume. So you want to make sure that you're comfortable with P theorem as well as the volume of cylinders, cones, and spheres. As I said before, there will be 7 questions in total, and all of them will be multiple choice for a total of 35 points toward your grade. So this Module 3 test will be graded on accuracy, not just completion. All right, let's dive in. As I said, we're going to go over 7 examples, and I will try to do it as quickly as possible so this video isn't crazy long, but I want to make sure that we address each of the types of problems that you're going to see. So example 1, or the type of question that you might see on number 1, is they're going to give you the leg length of a triangle as well as the hypotenuse, and they're going to ask you to find the other leg. So for example, and I'm not going to write the whole problem out, but let's say in the example, they tell you that the leg is 2 units, and they tell you that the hypotenuse is 4 units. And they're asking you to say, well, what's the length of the other leg, the other side of that triangle? So let's draw that triangle. That always helps me. And we want to put the little 90-degree mark in the corner. One of the legs they told me is 2, and they told me the hypotenuse is 4. The hypotenuse is always the side that is diagonally across from that 90-degree angle. The side that I'm looking for, the side I don't know, is this side, the other leg. So let's go ahead and write our formula for Pythagorean theorem. A squared plus B squared equals C squared. And I'm going to plug in what I know. I'm going to use 2 for A. You could put it in for B. You would get to the same place. I always choose to plug it into A. And again, I'm going to pick 4 for C because that stands for my hypotenuse. Step 1 was just substituting. Step 2 is let's deal with those exponents. So 2 squared is going to give me 4. I still don't know B squared. 4 squared is going to give me 16. My next step is to subtract 4 from both sides because I want to get that B squared all by itself. So my 4's are going to cancel out, and I'm left with B squared is equal to 16 minus 4, and that's going to give me 12. Now what I want to find out is what is the square root of 12, because I don't want to know B squared. I want to know what B is. So I actually need to come in here and do the square root of each of them. Square root of B squared gives me B, and I'm going to head to the calculator because I'm going to plug into my calculator the number 12, and then I'm going to hit that square root symbol. And when I do that, it gives me a crazy long number, and I am just going to cut it off to the 10ths place. So that's going to be 3.5. And again, I don't know the label other than the word units. You might see one of your answer options as the square root of 12. So you have 2 possible answers. You have the square root of 12 as one answer, or 3.5. Both of those would be correct. All right, question type 2 would be if they give you both of the legs, and they want you to find the hypotenuse. So let's take a look at example 2. And in this example, it says that the legs are 3 and 7 units. And they want to know what the hypotenuse is. So this is what that would look like. If I draw my triangle again, put in my right angle, my legs are 3 and 7. And what I don't know is this value over here, that hypotenuse, which is C. So if I go and I go to my formula, a squared plus b squared equals c squared, I am going to use the smallest number for A, and I'm going to use the 7 for B, so let's plug those values in. I don't know C. My next line is to square them. 3 times 3 is 9. 7 times 7 is 49. I don't subtract this time because both of my values are on the same side of the equation. I'm just going to go ahead and add them up. That gives me 58. And what I need to do now is I need the square root of 58. That is going to give me my value for C. So again, please have a calculator handy, whether that's on your iPad or on your phone or an actual calculator. I'm going to plug in 58, click that square root symbol, and I get a really long number, which I'm going to cut off to the hundredths place, and I'm going to put 7.62, and again, I don't know the label, so I just put units. Okay. The third example that we are going to go over is one you have already seen. In fact, you saw this on your mid-module quiz, and we're going to call this example 3. And the question says, Ms. Hill calculated the missing side length of one of these triangles using the Pythagorean theorem. Which triangle is it? And then we've got a bunch of triangles. So I've got like the triangle like this with a little curve, and it's giving me 2 values. They might give me a triangle like this, and it's got a curve here with some values on the side. They might give me a really wonky looking one. Awesome straight line I just drew for you there, which looks like this, right? And then the last one they give you looks like this. It has the square in it. So if you're looking at those 3 examples, this one's killing me right now. Okay, if you're looking at those 3 examples, which one could Ms. Hill use the Pythagorean theorem to solve? The only one that's possible is this guy, because the Pythagorean theorem only works for right triangles. How do I know that is a right triangle? I know it's a right triangle because it has this little notation in the corner. That box, that square, means that that is a 90-degree angle. So that is the only type. If you notice, these all had curved lines in the angle, showing that none of those are exactly 90 degrees. So the only one that's possible is the one that you see that has that square in the corner. Okay, let's take a look at example number 4. Example number 4 is going to give you like a real life situation and an actual triangle that they've drawn. So let's draw this triangle. And they're going to say that they want to know the length of the third side of this window frame. So you have a little triangular window. And on this side, they say that this is 50 inches long. And on this side, they say that it's 40 inches long. And so what they want to know is this length right here. And the only other clue they give you is they put the right angle notation there. So if I look at that and I look directly across, I know this side has to be C. The 40 I could use as A or B. Up to me, I'll mark it A. So what I'm looking for is side B. So if I start by writing my P theorem, my Pythagorean theorem, I'm going to plug in 40 for A. I don't know B. And I'll plug in 50 for C. Now, just in looking at that, you might get a little bit nervous because those are bigger numbers. Don't let them fool you. 40 times 40 is the same thing as doing 4 times 4 and just adding those two zeros on. So this is going to give me 1600. 5 times 5 with the two zeros. My next step is to subtract my 1600. Again, remember I have to subtract when my values end up on the opposite sides of the equation. So I'm going to go ahead and set up my equation here. If I subtract the 1600s, then they cancel. I bring my b squared down, and I'm going to subtract 2500 minus 1600. That's going to give me 900. My very last step here is to go ahead and do the square root of both. When I do the square root of b squared, that gives me b. And then when I do the square root of 900, and if you don't know what it is, you can totally go to the calculator, I'm going to get 30. And I want to go and use the label that I have, which is inches. So that means that that missing side, or the third length in that window frame, is going to be 30 inches long. Okay, example number 5. We're more than halfway there. Example number 5 says that they're giving you a figure of a location of 3 points that are around a lake. They tell me what 2 of those lengths are, and they want to know what is the distance, which of the following choices is closest to distance between points A and B. So let me draw this triangle that they're talking about. They give me this triangle. Again, I've got my right angle. And they label it like this, which is very common to the way we label a triangle. We label the points, or the angles, A, B, and C. They tell me that this length here is 6 miles, and this length here is 4 miles. So this would be considered side AB, or between points A and B. Which of the following is the closest to that distance? So what I'm looking for is this length right here. Again, I want to be able to know which one is C. This guy out here is C. It's across from that 90-degree angle. I will call this A. What we're looking for is B. Again, A and B are interchangeable, so if you decide you want to label that B, have a great time. Let's start with my formula. A squared plus B squared equals C squared. I know that A is 4. I don't know B. Oops, sorry, forgot the squares. And I know that C is 6 squared. So now, just like the one above it, I'm going to do the same thing. 4 times 4 is 16. 6 times 6 is 36. I want to subtract my 16 because my numbers ended up on the opposite sides. 16 minus 16 cancels. I bring down the b squared and I do 36 minus 16, which will give me 20. My very final step in these problems is to go ahead and find the square root. Square root of b squared is b, and I'm looking for the square root of 20. So again, go into that calculator because this one's going to have decimals. I'm going to enter in 20 and do the square root. That gives me 4.47, and that continues far off after that, but I just went ahead and rounded it to the hundredths place. And then I want to make sure I use my label of miles. Okay, let's go ahead and look at question 6. Now, question 6 is going to look at the Pythagorean theorem on a graph. So let's take a look at how we can solve this. If I go ahead and draw, I'm going to roughly sketch this so that you can see it. This will not be a perfect drawing as great as you can see on the actual test. So let's look at example 6. And I'm just going to sketch what this coordinate grid might look like. So there's my x and y. And I'm at -1, -2, -3, -4, -5, 1, 2, 3, 4, 5. And I'm just going to do the same up here. And they've drawn a line starting here at -2. And they've got a point at 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. So they've got a point that's up here. They're just giving me those 2 points, and they have labeled these points C and D. And I'm actually going to break out a ruler here to draw this line, and that's all they're giving me in my problem. And they say, what is the distance in units between C and D? So here's the simplest way that I can visualize this. A lot of people had a lot of trouble with the distance formula. So let me show you a little bit of a way that we can take a look at this. If I'm looking from C to D, if I'm looking for this distance, what I know is that this distance is 5, because I know it went up 1, 2, 3, 4, 5. And I know that this distance is 1, 2, 3, 4, 5. So I also know this distance is 5. What I'm looking for is that hypotenuse that goes from C to D. So I could use Pythagorean theorem and go a squared plus b squared equals c squared. This is my A, and here's B, right? The 2 sides. So if I plug that in, I can solve for C, or what that basically is just the distance of that hypotenuse, right? Because here's my right angle. That's the hypotenuse over there. So let's go and do that. 5 squared is going to give me 25. Again, 25. 25 and 25 is 50. And my very last move is to square root both the 50 and the c squared. So that gives me c. Again, I'm going to go right to that beautiful calculator because I know that that number is going to be a decimal. So I'm going to type in 50 and get my square root. That will give me 7.07. I do not know what the distance is here, so I'm just going to call it units. All right, thanks for hanging in there with me. I know this is a long video, but we want to make sure that we've addressed all 7 of the questions that you're going to see. Notice the first 6 were all about Pythagorean theorem. So if you understand anything in this unit, it really should be Pythagorean theorem. Let's look at your last type of problem that you're going to get. That type of problem is going to be a volume problem. Let's say they give me a cone, right? So they're just going to say, what's the volume of a cone? And they're going to give you the radius, they're going to give you the height. So let's draw a cone just so that we know in our mind exactly what we're talking about. Now, I'm not amazing at this, but I'm gonna do the best I can. I'm gonna channel my inner ice cream cone drawing because I do love some ice cream. Okay. And there, let's say they tell me the radius is 5. So that means this distance from the outer edge of my circle to the center point, let's say that that's 5 inches. And they tell me that the height of this cone is, let's say, 3 inches. So it's a really short cone. What they're talking about for height is that inside height, not the outside diagonal height. They're talking about the inside. Okay, so let's say that they told me this is 3 inches. I am going to use the volume formula for a cone. So for a cone, volume is equal to 1/3 pi r squared times the height. So I only need to know pi and the height. Step 1 is writing that formula. Step 2 is plugging in what I know. I know that the radius is 5, and that will get squared, and I know that the height is 3. Step 2, let's deal with those exponents. 5 squared is 25. Just like PEMDAS tells me, my next move is I'm going to multiply 25 times 3. That's going to give me 75. How do I deal with that 1/3 out in front? Basically, what you're going to do is you're going to divide the 75 by 3. Notice I haven't done a thing with that pi yet. 75 divided by 3, I'm back to 25 pi. Now what I'm going to go ahead and do is I'm actually, in my problem, it said use 3.14 for pi. So I'm going to go to the calculator and I'm going to multiply 25 times 3.14. If you do 25 times 3.14, you will get 78.5. Because my label is inches, I want to label it inches, and it should be cubed. Right? So all I did for right here was I plugged in 3.14 and I multiplied that. You might also see this written as cubic inches. That is the same thing in terms of your label. Okay? I really hope that these notes were supportive. Please, please, please use these notes with you as you go through and complete the final module test for quarter 3. It's been an awesome time helping you and supporting you, and I hope you guys have a great rest of your day. Bye.